Welcome everybody. This is day 2 of the VM Workshop 2021, and our next session is the IBM Cloud Infrastructure Center use cases and demo. And so with that, I'll turn it over to Stev Glodowski and his team.
Good morning, good afternoon. Welcome everybody. I'm glad to be here presenting at the VM Workshop this year, and hopefully we will meet all next year again in person. Last year, I was also showing a little bit on the IBM Cloud Infrastructure Center, and I want to introduce you to the product this time again, but from a different perspective. And I also have 2 people from our team that are joining us today, Rui and DCC, and both will run a small demo on 2 different use cases of Cloud Infrastructure Center during today's session. So I'll start with a quick overview to get everybody on the same page, and then we get right into the use cases, the different use cases we have for Cloud Infrastructure Center. I'll mention one opportunity that I think is very important for everybody to understand and to know. And then we already get into the second and the third part of today's session together with DCC and Rui with the demo. Okay. In general, what is Cloud Infrastructure Center? It is an infrastructure as a service solution for IBM Z and Linux One platforms. We are available since December 2019, and we're operating on a continuous delivery model, which means we are delivering new functionality and capabilities a couple times each year. Very important for us is our integration with the platform as a service layer. That's the layer where we have an OpenShift running, where we have VMware, where we have those things like Terraform and Ansible. And Cloud Infrastructure Center provides that integration with that layer for our platforms. So looking at that picture, we have here Cloud Infrastructure Center being the IaaS layer, the infrastructure as a service layer. And below of it, we have our infrastructure across compute, storage, and network. And Cloud Infrastructure Center operates to make this infrastructure ready so that it can be consumed by things like an OpenShift, like CloudForms, Terraform, VMware integration, and so on. And by doing so, we're connecting basically the layers of cloud computing, enabling you, our clients, to integrate Z and Linux One infrastructure into cloud, into hybrid cloud environments. Now, Cloud Infrastructure Center comes with a self-service portal, which is something very common in a cloud scenario. And on that self-service portal, the user and the administrator, they can all interact with Cloud Infrastructure Center as our graphical user interface. But everything that we provide via the self-service portal, we provide also via cloud, via command line interface and via RESTful APIs. And those RESTful APIs, and to be specific, OpenStack capable APIs, those are the ones that make it possible to integrate with the platform as a service layer here on top, so that someone who is an end user of OpenShift, for example, can work with OpenShift and under the covers OpenShift and talking through Cloud Infrastructure Center to our Z infrastructure. Okay, use cases. There are 3 main use cases for Cloud Infrastructure Center: infrastructure management, cloud automation, and cloud integration. Infrastructure Center, probably infrastructure management, probably the most obvious use case. So you can use Cloud Infrastructure Center to provision virtual machines, guests. You can provision them in a bulk, so it's not just a one-to-one deployment. And the product helps you to manage those virtual machines throughout their life cycle. You can define ones, capture them, make a snapshot, start, stop, delete, restart, all the usual capabilities that you would expect throughout the life cycle of your virtual machines. Cloud automation, our second use case. Here the focus is really helping a customer to provide cloud services and make them in the most efficient and easy way consumable, so that an end user is abstracted from any complexity, that an end user would not really have to know, am I on the Z platform or on something else? But still, I can use it. I can do the tasks, I can run the workloads that I want to run, and I can use Z infrastructure very conveniently under the covers. And third, and this is probably the most exciting use case, is cloud integration. And I mentioned this before, because of the OpenStack compatible APIs, the RESTful APIs that we come with, Cloud Infrastructure Center can integrate with the platform as a service layers and all the tools, the cloud tools and software that is running on that layer, and really being the linchpin between our infrastructure and those PaaS layer software. So now I have prepared 3 slides, one for each of the use case, to show you a little bit more what we're meaning by this. Infrastructure management, the obvious one here, provisioning virtual machines. You have an image, you deploy that image, creating a new guest, and you can start, stop, delete, do all those usual activities with your virtual machine. But you can also, on top of that guest, install on top of that Linux operating system that is deployed there, but you can install on top of that any database instance, any software that you need for your specific purposes. And then you can capture or snapshot that full image and make a so-called deploy template out of it. And the deploy template combines the information about which image to deploy with everything in it, and which network, storage, and compute configurations and parameters to utilize for that deployment. So a deploy template really contains everything that is necessary to deploy such an image in a very easy and convenient way. And this is what we also use very much in our second use case regarding cloud automation. So let's take a look. So in this use case, we're focusing very much on the self-service portal that comes with Cloud Infrastructure Center, because that self-service portal can contain your service catalog. The service catalog is basically the sum of all the different deploy templates that your cloud administrator has created. So we have on the right side the cloud administrator, and he's the person creating those deploy templates, all the different flavors for all the different use cases that your clients might have. And on the left side, we have the end users, and they contract those services. They use the service catalog to select a deploy template and get that template provisioned, virtual machine created based on that image with all the parameters. And by doing so, the end user, here in our case, for example, an application developer, that person really is completely abstracted from the underlying platform. That person does not have to have any skills on Linux 1 or on Z, but can select the purpose that he has in mind, and based on that, choose a deploy template, choose a service from that service catalog, and get a virtual machine with a Linux operating system, that being a SLES or a RHEL or an Ubuntu, and any software that has been pre-configured installed on that environment. By the way, this is also one of the use cases that the Linux Community Cloud is using Cloud Infrastructure Center for. They have those vast number of virtual machines that they have available for users to play with and try workloads on our platforms, and they utilize Cloud Infrastructure Center under the covers to make that possible. Now, coming to our third use case, cloud integration. In the previous picture, you have seen the service catalog and the self-service portal from within Cloud Infrastructure Center. Now, in this use case, we talk about a service portal that our customers have created themselves. Anything that you have created in your environment as a service portal, and you connect that service portal through the OpenStack compatible APIs that come with Cloud Infrastructure Center to the IBM Z and Linux One platforms. So you're not bound to the self-service portal and the catalog that comes with the product, but you can attach, you can connect any portal that you created by yourself for your own specific purposes also to the platform via Cloud Infrastructure Center. And the connection can be there via Ansible, via Terraform, CloudForms. We have a specific VMware integration where you could run on VMware vRealize and show environments on x86, on Power, on Z and Linux One, all managed from that VMware endpoint, but having Cloud Infrastructure Center in the middle to be the connection between VMware and the Z platform. So those are the three main use cases that we support with Cloud Infrastructure Center. I mentioned at the beginning, there's one specific case or one specific opportunity that I want to mention and make you all aware of. And this is the possibility not just to provision a SLES or a RHEL or Ubuntu guest with Cloud Infrastructure Center and manage those and provide them as contractable services for the cloud. But Cloud Infrastructure Center can also provision Red Hat CoreOS images. And since Red Hat CoreOS is at the foundation of any OpenShift cluster deployment, you can actually use Cloud Infrastructure Center to simplify the way how you install OpenShift clusters and nodes. And Rui, in just 2 minutes, will talk a lot more about this in detail, how Cloud Infrastructure Center can help to simplify that process together with OpenShift. And he will also talk about the Ansible playbooks that we have to automate that process. We have 2 blogs created, publicly available, where we describe all those steps for you also later on to read and to learn, and to give you a good overview how you can utilize Cloud Infrastructure Center, especially together with OpenShift. And with this, I would like to hand it over to Rui.
Hello, everyone. My name is Huang from IBM Cloud Infrastructure Center development team. So I will take next about 20 minutes to firstly, I will introduce OpenShift container platform on IBM System Z installation support status. Then I will focus on the introduction to OpenShift container platform ZVM UPI with Cloud Infrastructure Center. And at the end, I will demo how to create a Red Hat CoreOS virtual machine in Cloud Infrastructure Center. So let's start from Red Hat OpenShift installation on System Z support status. At first, we need to know what are IPI and UPI. So IPI is OpenShift installer provision infrastructure in manner of full stack automation. After OpenShift container platform installed, the cluster will manage the infrastructure. Well, UPI is user-provisioned infrastructure. Users need to create virtual machines, set up networks, configure storage to install OpenShift Container Platform. On IBM System Z and Linux 1, Red Hat OpenShift Container Platform only supports UPI. So currently, no IPI support, which means users have to perform lots of manual steps to deploy OpenShift Container Platform on System Z and Linux 1. And another problem is how to manage and maintain the infrastructure of OpenShift Container Platform. So that's why I want to introduce IBM Cloud Infrastructure Center to OpenShift Container Platform UPI install. Basically, Cloud Infrastructure can help to provision, manage, and maintain OpenShift Container Platform infrastructure, and it supports both ZVM and KVM UPI install. Of course, in this session, I will just focus on ZVM UPI. So next chart. Let's have an overview of ZVM UPI with Cloud Infrastructure Center. As you can see in this chart, Cloud Infrastructure Center can manage multiple ZVM LPAS and the lifecycle of OpenShift Container Platform nodes. For OpenShift Container Platform installation, Cloud Infrastructure Center provides image service to manage Red Hat CoreOS images, and also ignition config files. Also provides compute service and network service, working together to automate all steps that's creating Red Hat CoreOS virtual machine with network interface configured. Cloud Infrastructure Center also provides block storage service to support boot Red Hat CoreOS from FCP SCSI disks. And the Cloud Infrastructure Center provides multi-tenancy support to allow deploy multiple OpenShift Container Platform clusters in different isolated tenants or projects. This chart shows more details that how Cloud Infrastructure Center helps in OpenShift Container Platform ZVM UPI by comparing the difference between normal ZVM UPI and the ZVM UPI with Cloud Infrastructure Center. Just bring up some highlights here. With using Cloud Infrastructure Center, users can upload Red Hat CoreOS images and ignition config files onto Cloud Infrastructure Center image server, and then create Red Hat CoreOS virtual machine by sending just one API request or just a few clicks from the web UI. As you know, this is very important step in OpenShift Container Platform UPI install. And I will demo this later. Cloud Infrastructure Center also can help in day-to operations like OpenShift nodes lifecycle management, scale up, scale down, OpenShift master nodes and work nodes. I have no time to go through all the details for every step listed in this table. So just a quick summary here with using Cloud Infrastructure Center that's simplified and automated the installation steps will provide user much better user experience, and the less ZVM skills required to install OpenShift Container Platform. Also, because Cloud Infrastructure Center provides OpenStack compatible API, so it is very easy to be integrated into other solutions. The more, as shown in the third column in this table, we also implemented a collection of Ansible playbooks to help to automate all the steps in ZVM UPI. And those Ansible playbooks has been published onto GitHub, free for users to reference and try. So just a few charts and here. Next, I will show you some demos. So this is IBM Cloud Infrastructure Center web UI. As you can see, I have uploaded one Red Hat CoreOS image. This is a dusty image, also known as ECKD image. So let's trigger Red Hat CoreOS provision at first. Just choose this image and click deploy. Choose the flavor. We just use the Tini flavor. And the network. And also, because this is a Red Hat CoreOS, so you must specify a ignition config file. Can just choose the ignition config file from my local file system and click the deploy. Okay, it started to building. From this Cloud Infrastructure Center, this is another Cloud Infrastructure Center, my two different development environments. As you can see in this Cloud Infrastructure Center, I have already deployed OpenShift cluster. You can see 3 master nodes and 2 worker nodes. So in this Cloud Infrastructure Center, I will try to use try to create a deploy template for OpenShift worker node. Then use the deploy template to deploy a new OpenShift worker. First, choose the Red Hat CoreOS image. Then click create deploy template. Choose the flavor. We have predefined the flavor named OCP. As you can see, for CPU, 16 gigabytes memory and 30 gigabyte disk. Choose the network, and this is a deploy template, so you don't have to specify IP address. Just choose a network. And because we want to create a deploy template for OCP worker nodes, so we need to upload the OpenShift worker ignition config file here. This config, the ignition config file was generated by OpenShift installer. If you have experience to deploy an OpenShift cluster, you will know this. Just copy and paste the worker ignition here. Create the deploy template. Then we have a deploy template for the OpenShift cluster worker node. Then we use this deploy template to deploy a new Red Hat CoreOS virtual machine. Demo 1. And from here, you can specify a IP address. But if you uncheck this, the IP address will allocate from the IP address pool automatically. Click deploy. So, as you can see, the new worker node started to building. Let's go back to this SSE. It's already complete the provision, and the VM state became active. Let's try to connect to this CoreOS. Yes, this the operating system is also active. You can see this is Red Hat CoreOS 4.7. Let's back to this ICIC, IBM Cloud Infrastructure Center. Another thing I can show is before this session, I have pre-deployed Red Hat CoreOS virtual machine, which is boot from FCP SCSI disk. And from the Cloud Infrastructure Center storage panel, you can see there's a data volume. Actually, it's a boot volume with 10 gigabytes is used. By this virtual machine. Let's access to this CoreOS. You can see in this CoreOS have two FCP devices attached, one A0D and one B0D. And in the kernel command line, you can see there are several rd.z FCP paths listed there. Yeah. So this proves that the Cloud Infrastructure Center will support both boot from Red Hat CoreOS from ECKD disk and FCD SCSI disk. My demo almost complete. You can also check the console log by this feature.
Yeah, so a question that came into the chat was, does this work with pre-made images?
Yeah, for normal Linux distro like RHEL 8, yes, but for Red Hat CoreOS, we did not test it because Red Hat CoreOS is an immutable operating system. So if you want to pre-configure the Red Hat CoreOS, you just need to provide different ignition config files. How long does this build take typically? It depends on the root disk size. In Cloud Infrastructure Center, normally, for example, the first Red Hat CoreOS that I provisioned in this SSC just take 2 or 3 minutes to complete with 10 gigabytes root disk. But this worker node that I deploy, the flavor is with 30 gigabytes, so it will take about 10 minutes or even more. If there's no more questions, I'd like to turn to DCC to the next topic because I'm not sure how long it will take. Okay, it's active now. It's active now.
Oh, okay.
So my part's complete. Thank you.
All right. Thank you, Rui. Let me give DCC presenter, and then we'll change over to him.
Yeah.
Hi, everyone. This is DCC coming from the IBM Cloud Infrastructure Center development team. And since 1.3, I think IBM Infrastructure Center will ship with the monitoring service, also known as the telemetry services, which can help to perform the monitoring against the hypervisor as well as the managed VM. So in the next few minutes, I will give a brief about this monitoring feature along with the demo. So here's the agenda. So basically, the first I will give an overview of the monitoring feature. Secondly, I will show 2 typical scenarios that integrate the existing monitor infrastructure, like Prometheus and Grafana with the IBM Cloud Infrastructure Center, and then which will focus on 2 areas. One is the service monitoring, the other is the VM monitoring. And last, I will show a demo on that, some kind of the sample dashboard to monitoring the services of the IBM Cloud Infrastructure and the dashboard of the VM instances that being managed. And okay, here the IBM Cloud Infrastructure Center monitoring overview. So basically, IBM Cloud Infrastructure provide the monitoring from different angle. For example, after installation, of the IBM Cloud Infrastructure Center. It provides something like environment checker, which is also known as the something like installation verifiable program. It can perform multiple checking of the environment, like a CPU, memory, storage, services, and a firewall, etc., just to try make sure your environment is ready for production. And besides the environment checker, IBM Cloud Infrastructure Center also provides the health check, which will check the status of the system and the resource periodically, and like whether the management node or the computer nodes are healthy, or the backend storage the backend storage provider works okay. Sometimes it will check the storage provider like DS8000 to check whether the storage provider is accessible or healthy. And in case of it's running into unhealthy state, it will send notification to the admins. And moreover, IBM Cloud Infrastructure Center will shipped with the monitoring services, and also known as the telemetry services, which includes telemeter service, Glodowski service, and Packet services. And the telemeter services will collect and normalize the transform data that produced, and the Packet service will provide the metadata indexing event storage service that capture the state information of the IBM Cloud Infrastructure resource at a given time. And the Glodowski service provides a time series resource indexing metric storage service that capture by the IBM Cloud Infrastructure resources and the metrics associated with them. And one thing that I need to mention is that those services are disabled by default. You will need to enable them by using the ICS management commands as shown in the black box on this slide. And for the monitoring data, IBM Cloud Infrastructure Center support both the CVM hypervisor and the KVM hypervisor, and those two hypervisor will have the slightly different on those metric supports. And next, I will talk about how to integrate the IBM Cloud Infrastructure Center into existing IT monitoring infrastructure. Nowadays, that the Grafana dashboard are widely used for building the dashboard, and some are based on the Prometheus data source, some are based on other data sources like Graphite. And there are many open source dashboards that can be referenced and used as samples. I will take those as an example to see how the IBM Cloud Infrastructure can be integrated with them. I will focus on the two scenarios. The first scenario is about from the IT management perspective, how to monitor in the IBM Cloud Infrastructure and its services. And the second scenario is how to monitor the VM instances managed by the IBM Cloud Infrastructure Center. And I will demo those dashboards in the demo session. As for the first scenario, here is a diagram. So basically, it's how to integrate in the IBM Cloud Infrastructure with existing monitoring infrastructure. And this is a diagram shows how the IBM Cloud Infrastructure feeds its service data into the Prometheus, and how the Grafana can pick the Prometheus as the data source to build and display the dashboard. This was done by the means of the OpenStack exporter, which is an OpenStack project. It can pull in the data from the extended OpenStack API from the IBM Cloud Infrastructure and feed those data into the Prometheus. And there are many dashboards open source, and of course you can build your own dashboard with those metrics that are collected directly from the IBM Cloud Infrastructure Center. And here is a screenshot of the service status, and with that you will be able to see something like neutral state and etc. I will show those pages in the later slide, and also for the service status dashboard, you also have the service statistics like the overall memory, overall CPU, etc. And the second scenario I will talk about is monitoring the VM instances managed by the IBM Cloud Infrastructure Center. Since the IBM Cloud Infrastructure Center will have the self-service portal or can be integrated with OpenStack-based portal like the CloudForm, etc. And the self-service user can provision and manage the VM by themselves. Thus, from the IT management perspective, understand how those VM resources usage and its status is quite important for the something like the IT management, like capacity planning, etc. And here is a diagram of this scenario. And since 113, we embed the temperature switch, which can collect the VM instance data as well as the hypervisor data. After enabling the monitoring services, all those data will be stored in a time series DB, which is called the notch. And with the notch, you will be able to take it as a data source and to build a dashboard. And here is the screenshot of the VM dashboards, and here's something mainly about the CPU memory utilization along with historical trends. I will show that in the later demo. And also this screenshot is about the storage, network I/O, etc. Next part, I will do a quick demo. Okay, so here is a UI of the Grafana. So basically, you will be able to construct the dashboard within Grafana UI. And let's start it with the service dashboard. Yes, I already created that before this meeting, and as I mentioned previously, that this service data dashboard will help to IT admin to understand how IBM Cloud Infrastructure System status. As you can see here, you will be able to see whether there were any novel agent is down. In case it's down, it will turn red, and if everything is okay, then it will green, and you will be also able to see the single agent status and along with neutral agent status, etc. So basically, these part of the data are mainly focused on the service status. Moreover, you also provide resource usages. Resource usage, as you can see, it will display the information about our overall memory that consumed by the IBM Cloud Infrastructure, and also for the CPU that it used, and along with its local storage and neutral statistic and keystone statistics and virtual machine information. Oh, and along with the single volume and glance image, basically these are overall information for the IBM Cloud Infrastructure Center. So this dashboard is for the service status of the IBM Cloud Infrastructure. Next is about the instance dashboard. Instance dashboard is about how we manage how the monitoring information of the managed VM. So from this dashboard, you will be able to see the hypervisor information like hypervisor CPU utilization and memory utilization, along with volume information and virtual CPU information and the memory information, along with those virtual machine information. As you can see in this environment, I have 2 VM and 1 VM. The first one, the left one is running at a high CPU. As you can see, I ran some program internal that inside of that VM, and you will be able to see that its CPU is nearly about 100%. And moreover, you can see you will be able to see this historical data of the CPU utilization. As I mentioned previously, IBM Cloud Infrastructure providing the notch database, which is a time series database. So you will be able to retrieve historical data based on that to build the charts and widgets. And Besides that, also you will also for the VM dashboard, you will also be able to see the memory usage and the VM disk usage of those VMs, and you can see that each VM information will be listed as a legend here, and also for the disk usage, you will be able to see all those disk information listed here. And besides the memory and disk, you will also be able to see the disk device write bytes or this read bytes information along with the network interface I/O, like outgoing or incoming byte rate, etc. So basically, it will help to understand how those virtual machine behaves. And besides that, and let me switch to the terminal. So basically, these are the Grafana dashboard is pulling the data from the backend, from the IBM Cloud Infrastructure Center. And let me switch. So basically, IBM Cloud Infrastructure provided the API, OpenStack standard API to feeding the data. For example, you will be able, in the demo, I will use the CLI to do that, but basically those CLI was built based on the REST API. So which means in case your own application would like to get those data, you will be able to fetching those data from the standard OpenStack API. We can see. We can see we will be able, for example, we will be able to see that the resource information in this environment, and from the type we can see that there are node compute and also instant network and instant disk and cloud algorithm metrics. So basically, these are the resources the store have been monitoring and collecting these systems. And moreover, about the, when we talk about the monitoring, we will care about the metrics. And let's see what kind of metric in the system. So basically, from here, you will be able to see something like the memory utilization and the disk device usage and read bytes, and also along with the computer nodes, the CPU percentage, total volume, all those kind of information metrics are recorded, are stored in the GNOME database, as I mentioned. And moreover, as I mentioned, the GNOME database is kind of time series DB. Let's see, let's see what if we will be able to see. We can. It also provides certain kind of API to fetching these host data. As you can see, for this command, the command I use just pulling the historical data of the memory usage, which is, it will be collected every 5 minutes, and so basically you will collect, since this VM is running for some days, so it will collect. It has a lot of records showing those information. Okay, so this is my demos.
Thank you, Bill, very much for having us showing a little bit more about Cloud Infrastructure Center. Very much appreciated.
Well, thank you. I know I learned a lot, and thank you. I know, Steve, it's getting late for you, but it's really late for Rui and DCC, so I appreciate them staying up late to work with us. And hopefully we'll hear from you again in a future workshop.
And everybody enjoy the VM workshop.